Hello and welcome to today's math tables, equations, and graphs of functions lesson. So what we have here is your worksheet. So what this is asking is to match these equations to each of the graphs. So first we're going to read what these are in order to see, hey, where is this going to match? And then look at the graphs. So it says D equals 60t, where D is the distance in miles that you would travel in t hours if you drove at 60 miles per hour. So think about it like getting in a car. If I was going to go to California and I drove 60 miles per hour, I'd only get 60 miles away from my house. At 2 hours, that would be 60 times 2. I would be 120 miles away. And so on and so forth. So I'm actually going to look at here which graph matches it. So I'm going to start with A. My x-axis is counting by ones, which is perfect because we're dealing with hours. So this could be a possibility, but I know after 1 hour, since I'm going 60 miles per hour, after 1 hour, I should be at a distance of 60 miles. So what I'm going to do here is start at 1 and go up, and here's where my graph is. Is that 60? No, it's less than 10. So I know that this cannot be matched to A because 60 would be all the way up there. So I know A is not the option for the first word problem here. Well, let's try B. If my x-axis, which is horizontal, if my x-axis is hours, and I go travel 1 hour, let's see. Hey, that looks pretty accurate. I have 50, 100, 150, 200. All right, so this is a contender because this is above 50, because 50 is about right there, the 50 mark. So I know it's above 50, meaning it could be 60. All right, but let's double check our last one here. C. Oh no. There's a lot of reasons why it can't be C. One, our axis can count by 20s, that's fine. But the biggest problem here that doesn't match our graph or our story is it's decreasing. If I'm going 60 miles per hour, I'm going to constantly be increasing my amount each time. So it can't be C. So our best bet is graph B. All right, so it says here in the second one, we're going to label each axis independent and dependent variables. So the x and y axis. So my x-axis, since I'm going miles per hour, hour or time is going to be on our x-axis. And on our y-axis, it's going to be miles. So distance. Whoa. Okay, so distance, which would be miles. And how I can figure that out, remember, we have y equals mx plus b for our linear equations, where y is always going to be our y-axis, right? The axis that goes straight up and down, while our x-axis is going to be the one that moves left to right. So each time I go per mile, I'm going to be increasing, and that's how we're going to label it. All right, so let's see. Q equals 50 minus 0.4D, where Q is the number of quarters and D is the number of dimes in a pile of 1250. All right, so first off, I need to know, okay, let's look at my equation. In our standard y equals mx plus b form, I know that it's always, the slope is sometimes always positive. And it's always attached to the letter x. In this case, our x is d. So the first thing I notice about this equation is our slope is negative. So our slope is negative, meaning our line is going to go straight down or decrease from left to right. So let's look at the pile. Let's look at our options here. So B, we already found. A, let's see. Well, if I have 1 dime, right, because our x-axis is going to be dimes. So if I have 1 dimes, I have less than 10 quarters? Well, I know a quarter is 25 cents. If I have less than 10 quarters, I'm going to have a lot less money and not go anywhere near $12.50. So A can't be an option. C is going to be our best bet here. And here's why. Our x-axis is going to be D for dimes. So we're going to have the number of dimes. And also the reason why it's D is because it's in our equation. We're multiplying it by a number in order to get the number of quarters, Q, that we need. So our y-axis is going to be number of quarters. Oops, that's okay. So I know that graph C is going to be our B option. So I'm actually going to put the equation here with it. You don't have to. I just want to make sure that I have all of these completed so that way I can process of elimination everything, right? But even if I started with this first one here, it says area, so A equals pi r squared, where A is the area of the square in centimeters and the radius is r in centimeters. So obviously what I can tell is, remember, y is always by itself. The y-axis in an equation is always by itself. So in this case, my y is going to be A, and A, if I look over here, is area. So my y-axis is going to be labeled area. And the variable, the quantity it's going to be represented as is centimeters squared. When we're dealing with area, area is always squared. And it tells us right here, squared centimeters. That means my x-axis right here is actually going to be labeled radius, which is also in centimeters. So even though this is a process of elimination, anytime if we plug in a number, let's say we actually didn't know any of these and we didn't know any of these reasoning skills, the one thing we do know is to plug in a number. So if my radius is 1 for this problem, right, all I got to do is plug in 1 for r and take it squared. Well, I know 1 times 1 is 1. And I definitely know that pi is 3.14. If you didn't know, woohoo, you learned something new. Anything times 1 is just itself. So I know the area for 1 radius, 1 centimeter radius, is going to be about 3.4, which 100% makes sense because 5 is about right in between and it's a little bit less than 5. So we did our first step here and we did our second. Now we're going to be moving to our third step here. So it says for each function, what is the input and what is the output when the input's 1? So all we need to do here is take our 3 equations. So D equals 60t. Let me look at the other ones. Q equals 50 minus 0.4d. And then our last equation, A equals pi r squared. Well, we kind of already did A over on the other side, so I'll just redo it. So if I have an input, input always is the x value. Always, whatever you're going to put into the equation, so in this case r, I'm going to put a 1 in, squared, that is going to be our input. Because remember, input is x's, outputs are y's. So again, we have 3.14, and if we multiply those together, what we're going to have is 3.14 times 1. So the area for an output of 1 is 3.14 centimeters squared. Now area is the only time we have the the increments squared. So inches squared, centimeters squared. So now what I'm going to do is do the same thing with the other ones here. Whoa. What I'm going to do is I'm going to take a 1 and put it in for this letter D. And I'm going to write everything else down. or bring it down so I know what to do. 0.4 times 1 is just going to be itself. Remember, anything times 1 is just itself. I'm going to add a 0 after this because what this really says is 0.40. So if you put this in your calculator and you take 50 and subtract 0.4 from it, you're going to get a total answer of how many quarters there should be. 49.6 quarters. So basically 49, almost 50 quarters to get exactly $12.50 from the original problem. Okay. So now we have 3 here, and the third one here. D equals 60t. I'm going to do the exact same thing. My input for this is t. So in this case, I'm going to put 1. If I went 1 hour of driving, how far did I travel? Well, 60 times 1 is 60. So I traveled 60 miles so far in my cool adventure. And those are going to be those final problems here. Now, I'm going to go over Wednesday's problem, which we didn't get to in class, but I'm definitely going to go over this one and give you some hints to think about for tomorrow. Or, I'm sorry, Wednesday. So, Karen was running around the track. The graph shows the t in time he took to run various distances, d. So, the table shows the time in seconds after 3 meters. So, d is the distance, and t is time. So, we have our x-axis and our y-axis. How long did it take Curran to run 6 meters? Well, I know my x-axis is meters, because that's what it says. So I'm going to go to the 6 underneath the meters and go all the way up until I hit my graph, which is going to be right there. So this 2, my y-axis is time. So how long did it take? It took 2 seconds for Karen to run 6 meters. How far had he gone after 6 seconds? So now, instead of looking on the x-axis, what I'm going to do is look on the y-axis here. At 6 seconds is what I need to find. So if I go straight over, boom, I'm going to hit 6 seconds. And if I keep going down, it took him 18 meters to run. So how far did he go in 6 seconds? 18 meters. You can also look over here too on the graph and see that this verifies. So at 18, a distance of 18, he went 6. And then for 6 meters, it took him 2 seconds. So now you're going to estimate the time he had run in about 19.5 meters. So I want you to answer these last 3 questions. Those are the first 2 for Wednesday's lesson. And I want you to see when you come in if you got the same answers. And then estimate how far you could run for 4 seconds. And remember, these are estimates. They don't have to be exactly what they are.